Hello, we're going to discuss the quadratic formula today, which should be a review from Algebra 1. And then I'm going to introduce a new thing called the discriminant. So, quadratic formula. The good thing about the quadratic formula is that it always works for any quadratic equation. However, we have to be very careful when using it because it's very easy to make a mistake. What I want you to do right away is I want you to put parentheses around each letter of the quadratic formula. That way when you start plugging in numbers in for those letters, you remember to put those in parentheses. In order to use the quadratic formula, your quadratic equation has to be in standard form and it has to be equal to 0. So it has to look like this. Okay, please do not try to use A, B, and C unless it looks like that. Okay, and when we have this, then we are able to solve this equation, and that is typically helpful for finding our x-intercepts of our quadratic, of our parabola. So visually, here's what we're doing. We could have a parabola that looks like this, and then the two x-intercepts would be where it crosses the x-axis. So this would be two x-intercepts, and that's what we would call two real solutions. And the reason I'm calling them real is because these do not involve any imaginary numbers like the I that we were talking about in the last video. And then we could also have a parabola that looks like this, where it only crosses or touches the x-axis once. So that means I have one x-intercept, or another way of saying that is I have one real solution. And again, when I say solution, I'm talking about solutions to this equation up here of our standard form equal to 0. And then the last scenario we could have is a parabola that doesn't touch the x-intercept at all. So that would mean it has 0 x-intercepts, which we could say that has 0 real solutions. But the reason it doesn't have any solutions is because when we solve that, we get two imaginary solutions. So remember, imaginary means that it's going to have that I, the number I, in its answer. So we'll look at some more examples with that. So let's use this. Let's solve this equation, and we're going to state the number and types of solutions. So in this first example, it is already in standard form, and I have A equals 1. Remember, that's a 1 in front of there. B equals negative 16, and C equals negative 36. So I'm going to plug into my quadratic formula. X equals negative, then I'm going to put parentheses and put my B number in there, which is negative 16, plus or minus square root. Then I'm going to have parentheses B squared, negative 16, and I'm going to put the squared on the outside of that parenthesis, minus 4, parenthesis 1, parenthesis negative 36. All of that is over 2 times 1. So that's the plug-in. Make sure you're good with the plug-in and use parentheses. Now you could use your calculator to help you do these calculations, or you could do it by hand. Just depends on how good your mental math is. So the first thing we're going to do is simplify. I've got a negative times a negative. That's going to be a positive 16. Then I'm going to work underneath the square root. When I do negative 16 squared, since that negative is always going to be inside the parentheses, that number in that location will always be positive. So I'm going to do negative 16 squared is going to give me positive 256. Now when I do the negative 4ac part, I would treat this as negative 4 times 1 times negative 36. So if I do that, a negative times a negative will be a positive. So I'm going to get a positive number, and that number is 144. And all of that is over 2 times 1, which is just 2. So all I did was kind of do all of the parentheses part and make sure I simplified that. Now what I'm going to do is work underneath the square root. So I'm going to just add those two numbers together. So that's going to give me 400. So I'm going to have 16 plus or minus the square root of 400 all over 2. So now we're going to use what we know about square roots. And the square root of 400 is actually a perfect square. We haven't talked about that one, but if you type that in your calculator, you actually get 20. So this is 16 plus or minus 20. The square root of 400 is just 20. Okay, and that's all divided by 2. From here, I want to remind you that this plus or minus means I have 2 answers. So those 2 answers involve doing 16 plus 20 divided by 2 and 16 minus 20 divided by 2. So let's do the top one first. 16 plus 20 is 36, and then 36 divided by 2 is 18. So that's one of my answers. Now the bottom, 16 minus 20 is negative 4. Negative 4 divided by 2 is negative 2. So that's my other answer. So notice that I have 2 real solutions. And I know they're real because they do not have I in the answer. So now let's look at these next 2 examples. Notice that in these next 2 examples, they're not already in standard form. So in this example 2, I'm going to put it in standard form first. So again, I want 0 over on the right-hand side, so I'm going to cancel that 6x. So I'm doing minus 6x. That way I get 0 on the right. Now on the left, this 6x does not combine with anything, so don't try to add or anything like that. We're just rewriting. So that's 9x squared minus 6x plus 1. And notice now it looks like it's in standard form. So I can identify my A is 9, my B is negative 6, and my C is 1. So now let's plug in to the quadratic formula. And again, make sure you're using parentheses when you plug into the quadratic formula. So I'm going to have x equals negative parentheses b plus or minus square root parentheses b squared minus 4 parentheses 9 parentheses 1 all over 2 times 9. So now let's simplify. I'm going to take care of all the parentheses. So this first parenthesis, negative negative 6, is positive 6, plus or minus. I'm going to do negative 6 squared, which is going to be positive 36. Make sure you're putting those parentheses in to get the appropriate number. And then if I do negative 4 times 9 times 1, that gives me negative 36. And that's all over 2 times 9, which is 18. So now we're ready to subtract underneath that square root. So 36 minus 36 is just 0. So I have 6 plus or minus 0 all over 18. So again, you might be able to see this right away, but I'm going to split it up just like we did on the last one. So this means I have 2 different answers. I have 6 plus 0 over 18 and 6 minus 0 over 18. But watch what happens. When I do 6 plus 0, that's just 6. And 6 over 18 reduces. Don't forget to reduce. Divide them both by 6. So that's going to be 1 over 3. So this is giving me 1/3. And then 6 minus 0 is just 6. And then 6 divided by 18 is also 1/3. So I got 2 answers, but they're the same answer. So we say that that's just one real solution because it's the same number. So that's how we would get that one type that only touches the x-axis once. All right, so let's go back up here and do example 3. I'm going to draw a line down here. So example 3, again, it's not in standard form, so I need to put it in standard form. I want 0 on the right-hand side, so I'm going to add 3. So I have 0 on the right-hand side. 3 does not combine with anything. They're not like terms, so don't add 3 to anything, just rewrite it. And now we can identify the A, the B, and the C. So A is 5, B is 2, and C is 3. All right, so let's do the formula. X equals negative B plus or minus square root b squared minus 4ac all over 2a. So now let's simplify. So this is going to be negative 2 plus or minus square root of 4 minus, I get 60 here, all over 10. So now I'm going to subtract underneath the square root, and that's going to give me negative 56 all over 10. So if we were to try to do that in the calculator, we would normally, in Algebra 1, we would say, oh, there's no solution, we can't do it. But now we know better. Now we know we can split up the square root of negative 56. We can split that up into the square root of negative 1 and the square root of 56. And now the square root of negative 1 is I, and I have square root of 56. Now what about square root of 56? Can we pull that apart into a perfect square? Yeah, so this can be split up even more into square root of 4 times square root of 14. So if I rewrite that, that's going to be, I'm going to bring down my I, I'm going to bring down my square root of 4. Square root of 4 is 2, and then I'm going to have my I, and then I'm going to have my square root of 14. So that's just kind of my side work over here. Okay, I'm going to go back to my quadratic formula and replace that. So the square root of negative 56, that's going to be 2i square root of 14 all over 10. So the only other thing we need to do is we need to make sure that we are reducing. Look at all of your numbers that are not underneath the square root. That's here, here, and here. We want to reduce all three numbers by the same. So we want to reduce them all, divide them all by the same number. So I can divide them all by 2. So that's what I'm doing here. So if I divide each of them by 2, then I'm going to get x equals negative 2 divided by 2 is negative 1, plus or minus. And then 2 divided by 2 is 1i, or you can just put I. Keep the square root of 14 there. And then 10 divided by 2 is 5. So the big thing about the quadratic formula is if you still have a square root in your answer, you need to look to see if you can reduce in all three spots. If you can't reduce in all three spots, then leave it alone. And then this would be our final answer. So what type of solutions do we have then? Well, this has I in our answer, so really all that means is we have two imaginary solutions because it has the I in the answer. So we know that that parabola would not touch the x-axis at all. All right, so then now let's go to the back and talk about the discriminant. This is probably a new topic for you. And the discriminant, all it is a shortcut. It tells you how many times the graph is going to touch the x-axis. And what we're doing is the discriminant is this formula right here, the b squared minus 4ac. And I don't know if that looks familiar to you or not, but that comes from the square root part of the quadratic formula. So that's all that is. So we're just looking at the number that's underneath the square root. So if that number underneath the square root is greater than 0 means that it's a positive number, then we know we're going to have two real solutions. All right, if that number underneath the square root is exactly equal to 0, then we know we're going to have just one real solution. And then if that number underneath the square root is less than 0, remember less than 0 means it's a negative number, then we know we're going to have 0 real solutions, or in other words, we're going to have two imaginary solutions. And I want you to look back at the 3 examples we just did. So in that first example, notice the number underneath the square root was right here. So 400. 400 was a positive number, and we got two real solutions. In the second example, the number underneath our square root was 0, and that meant that we had one real solution. And then the number underneath the square root in the second one, negative 56, that was negative number, and that's why we ended up getting two imaginary solutions. So that's how the discriminant works. It's just looking at that number underneath the square root. So in these next four, all we're going to do is do the discriminant part, the shortcut, and we're going to determine the number of real solutions. So make sure it's in standard form, and then label your A, B, and C. And then plug into b squared minus 4ac. So 6 squared minus 4 times 1 times 4. So that's going to give me 36 minus 16, which is 20. Since 20 is a positive number, then I know that this is going to have 2 real solutions. All right, and that's it. So let's do the same thing for example 2. A is 1, B is 6, C is 10. So if I do b squared, 6 squared minus 4 times 1 times 10, that's going to give me 36 minus 40, which is negative 4. Okay, negative 4 obviously is a negative number, so that means we're going to have 0 real solutions. On example 3, do the same thing. A is 1, B is negative 5, C is negative 5. So I have b squared, make sure to put that in parentheses, minus 4 times 1 times negative 5. So I have 25. This is negative times negative, that's plus 20. So that's 45. 45 is positive, which means there's 2 real solutions. And then in example 4, A equals 1, B equals 8, C equals 16. So I'm going to do 8 squared minus 4 times 1 times 16. So this is going to give me 64 minus 64, which is 0. And if I get 0, that means 1 real solution. So this is a review of quadratic formula and the discriminants. And in class, we will discuss some more physics problems and word problems.